Hi there. So today I thought I'd come back with another quick video about combination of both surds and geometry. So I'm going to start with quite an easy question. It's a trapezium. It's a bit wonky, but the height we're given as √5 minus 2. Then side A is just √5. And side B, the base, is √5 plus 6. So I asked to find the area, but it's in the form √5 plus c. So I know the formula for the area of a trapezium, which is a plus b over 2 times h, or as my Year 7 maths teacher used to say, half the sum of the parallel sides times the distance between them. So we can just input our values, really. So a √5 plus b √5 plus 6 all over 2, and then times √5 minus 2. Or in other words, 2 √5 plus 6 over 2, and if I put them in the brackets, and I can divide 2 √5 by 2 to get just √5, and 6 divided by 2 is just 3 times √5 minus 2. And we're just going to expand these brackets. And we know that when we times two roots, it's essentially squaring it, and squaring a square root just cancels out. So √5 times √5 is just 5, then 3 √5 minus 2 √5 minus 6. So we get 5 plus √5 minus 6, or √5 minus 1. I've also got another area question, but this one's about the triangle rather than the trapezium. So here we've got one triangle A, B, D, and in the middle of it we've got another one A, C, D, and we're trying to work out the area of this shaded section. A to D we know is √2 over 2. Then CD we know is √3 over 3. And we know BD is √2 over 2. So I'm going to start by working out ADC, which is essentially just, if you know the formula for a triangle, is half base times height. We can just say that it's half times √2 over 2 times √3 over 3. So in other words, if we're timesing fractions, we're just multiplying the numerator sections and the denominator sections separately. So 1 times √2 times √3 is √6, then 2 times 2, 4, and 4 times 3 is 12. So the area of ADC is √6 over 12. And if I do the same thing with ADB, so again, half base times height, we can say that it's half times √2 over 2 times √2 over 2 again. So I guess ADB is an equilateral triangle. But again, same thing, 1 times √2 times √2, and we know that, same as before, if you multiply a root, it's essentially squaring a root, which cancels out, so we just get √4, or in other words, 2 over 2 times 2 times 2, or 2 cubed, which is 8. So √4 over 8 is 2 over 8, or 1 over 4. And what we're looking to do from here is just take away ADC, this small one here, from ADB. So essentially 1 over 4 minus √6 over 12. And considering this turns up in a non-calculator paper, you'll just have to leave it like this. So luckily enough, there wouldn't really be any more steps. That's it, folks. Thanks for watching.